Good afternoon, ladies and gentlemen, and welcome back to ET 2015, where we have David Pukta building a BioGem cell. This is a unique tech session starring David Pukta. You will not see him or myself personally, but you will see the magic of the cell. And now we commence O Festival.
Hello, my name is David Pukta, and thank you for joining me on this tech section. And it was a pleasure for John and Tesla Tech to be able to put this on at last minute for me. What we're going to be doing here is we're going to be building a BioGem cell, electrical generator. This is not a battery. It's not a galvanic reaction. This is the superconductive electrolyte. This is gold, graphene, gold, microbial electrolyte number 26. When you have, I'm going to build and speak at the same time so we can get through this as quickly as we possibly can. The negative electrode is aluminum. The positive electrode is stainless steel. We're going to be using graphene here as a capacitive. But this is not just graphene. This graphene was reduced from CO2 from coal-fired gas, from CO2 plants. So when you have CO2 problems and you don't know what to do with the CO2, we have processes that we can take CO2, which was arguably a difficult problem for our ionosphere, and now we can turn it into graphene, superconductive material used in the computer industry or capacitors or anything. Now you guys have all been paying attention to graphene. And what we're doing is I'm just taking regular filter paper and adding the graphene to it. And I'm being hasty, so I would normally pay a little bit more attention because it's arguably a very valuable commodity. Okay? First, while this is just sitting here, there's no electrical here. We're just using the graphene as a capacitive. The voltmeter is set to millivolts. It's okay. Thank you. Okay, millivolts. So this is called a microbial hydride fuel cell. It's my own class of fuel cells because it does not fit in any other kind of fuel cell. It's microbially activated. The gold, monatomic gold, gets caught in the graphene. The capacitor, you can see we've discharged the capacitor. Now we're just going to take a positive and a negative, and it makes voltage. Okay? These are just taped together cells, so all I'm doing is pushing on it to make the contact between the microbial electrolyte and the electrodes. You get 577 millivolts. We're just going to do a quick count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm going to disconnect BioGem, and we're going to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, let's just call it 55. So you watch the capacitor charge up and discharge. This is a 0.85 microfarad capacitor with 2,000 volts DC. So there's a lot of capacitance in this capacitor, arguably however you want to look at it. Now we're just taking we've put the graphene on top of the aluminum. This is just packing tape. We've got a postage stamp here to show you the size of the electrodes. And we're just going to put 1, 2 drops. Let it saturate the filter paper. Three drops, okay? Stainless steel electrode. Put it over the top here. Now my lovely assistant is going to be helping me, Eli. Just press in the center of the electrode. Okay. Okay, all you guys are messing around with crystal onyx and crystal cells and everything that you're trying to understand why the salt energy has it. Remember, monatomic gold comes from salts. We can get it out of salts. We've got John Hutchison when he built the first cells, Bedini, Linderman, Chuck Rothermeier. There's just a handful of great guys. What this does, it just takes it down to a finite art to get to the bottom of why my theory is why the flower of life was even represented as sacred geometry and what they were trying to tell us. And this is what we can see in the microscope. We have a little bit of a problem. I can't get to this electrode here. Just cut that out. I'll do it. Yeah, I'll do it. It's fine. I just need to be able to get to touch it because this is kind of a quick demonstration. That's good enough. Okay. So now we have a basic BioGem here. We've got the electrode the size of a postage stamp. Put that paper back on top of there. Okay. So now we're going to hook up the positive electrode is the stainless. Hopefully we can get it. The negative electrode is the aluminum. And we're going going to hook it to the positive and negative, okay? Okay. And now we've got 700 millivolts, okay? Charging up this capacitor. So we did not charge this. It does not need to be charged, and it has enough energy density to charge a lithium-ion battery. We can short circuit it here and short circuit the capacitor, and we're short circuiting BioGem. Some of the effects here that you've seen are not going to be strange to you guys. You guys are playing around with crystallonics. You're going to see the same effects in your crystal cells, but this, like I said, this just takes it to a refinite way and a proof of what we see in the electron microscope. The video that you just saw was an artist's rendition of what we see, and then I'm going to show you here quickly what we see in the light reflective microscope of what BioGem does. Okay, you can move your hand. Okay, I'm going to put this into the camera here, and you can see that. As a golden graphene crystal, it answers the questions of cold fusion. Okay? You still see that? Thank you very much. If you have any questions to answer, I can answer those questions quickly. If you would like me to change the demonstration and do something, I can do that quickly while we have a couple of minutes here.
Okay, if anybody'd like to ask a question, line up right here, right by my hand. Or actually, you know what? Let's use the mic, the question and answer mic.
I'm not
Go ahead.
Let's take a question here from...
Question and answer mic. Go ahead. Yeah.
Yeah, I was curious, what's the yellow water?
I said that in the beginning of the demonstration. It's gold, graphene, microbial electrolyte.
How do you get in a liquid form?
It's proprietary. I'm showing you that the cells work and how easily they work. The processing of this is a proprietary. It's my own. It's not open source. I apologize for that.
Is that solution gold chloride?
No.
And the graphene, where do you get that?
We grow it microbially.
You what? You grow it?
Correct.
Oh.
Comes from microbials.
Thank you, David. The picture you showed us of the graphene with the gold inside,
Yes.
it looked like it was on a cell phone. Is that a previous image, or is that something that is from this particular experiment?
This liquid from a previous photo and electron light reflective microscope.
Okay,
Refractive.
identical
Refractive.
experiment, but previously.
Yeah, but it's this liquid.
Okay,
Right.
thank you.
Any other questions? I heard another question out there.
How long do the cells last?
They are eternal, not immortal. That's a great question. If you have something that's nuclear, you should not be allowed to turn it on if you cannot turn it off. Microbial fuel cell BioGem is able to turn off. What happens, and the reason why this discovery was not understood until I perfected the processes of this, is because when the gold, monatomic gold, has an elliptic shell in its outer electron, we've represented that to you on the video. As that electron spins around, it's in elliptic orbit. Physics says that everything wants to be in equilibrium, the first law of thermodynamics. Well, when it gets caught within the graphene lattice, the graphene picks it up like a generator, BioGem, a little microbial generator at the atomic level. You guys have all experienced this in looking for crystallonics and the zero-point energy field. This creates electricity. The little generator creates electricity. It's the foundation blocks of life. This is what was being told by us by the flower of life. Here's the best part about it. All it takes is oxygen to knock out the monatomic gold to allow the gold to attach to another gold atom and stop the elliptic shell, dropping it from a monatomic to a gold molecule or crystalline lattice. Then the energy stops. So the name microbial hydride fuel cell is very self-explanatory. It must stay wet. Once it gets dry, it will not regenerate. So you can have arguably eternal power until you need to turn it off. That's the ultimate power source. Clean, we have radioactive meters, Geiger counters, and testing to look for any radioactivity here. It's not. And then ultimately it's proven because you can simply turn it off. So this is charging this capacitor. But there was a question out there that I heard, but we're going to say it again. Is it how many amps does it have? We'll disconnect the capacitor. And we'll go straight on the cell and we're just going to find out. You can charge banks of capacitors with this. No problem. So now we're going to move the voltmeter from voltage to amperage. We're going to go to microamps. Okay. So we've got 200 and plus at peak, 200 microamps. Remember, we're drawing. So under a draw, I'm just going to try to get a steady draw and see if it'll flatten out. 180 microamps. Okay? Times that times the voltage, and you get your watts. They average about 65 microwatts, but this cell built very crudely with aluminum and stainless steel and electrolyte weighs 1/10 of a gram. The best lithium-ion batteries for that energy density weigh 0.6 of a gram. Now, I owe a lot of credit to the understanding of this to a very good friend of mine, Chuck Rothermeyer, Captain Bay, who's arguably one of the premium researchers in crystallonics. And so Chuck is fortunate enough to be here today, and I think he has a question for me. So.
Oh, I haven't asked you. Is it solution in water?
It's condensed very well, but it is in number 2 lab grade distilled water. So the water is perfectly pure, and we use the water as a holding medium.
That was 180 milliwatts at what voltage again?
600, 700 millivolts.
Very impressive.
Thank you, sir.
I have need of several 7-watt power sources. Will it be able to upscale to that size? When would it be marketable, and what might it cost for a power cell of that size? Thank you.
I'm very happy to answer that question in the best terms I can, and I'll be very frank with you. I have a project that I'm working on with Mercedes-Benz with one of their electric cars, and the battery out of the car is run by Tesla Motors, which is Elon Musk's company, and BioGem, and the circuitry that I'm developing will charge that lithium-ion battery in that platform, which allows you to basically charge a lithium-ion battery. from a biogem that has an internal power source. So yes, the answer to your question is, it can be scaled up. Russ Grease, I asked him to please be quiet until I announced it. He has live stream on his YouTube channel of running biogem and running LED. It's been running for, I don't know, a month now or something like that on it. And he built a small static circuit to switch it on and off and run the LED consistently. That's a 2-volt LED. And there's other gentlemen that have testing and live stream, and that's on my YouTube. I can't give you the link because I don't know it, but I can pass it along. Next question, please. Hurry up, sir. We don't have all day long.
Love you, David.
What's going on, Chuck?
I got 2 tests for you.
Okay.
Instead of using biogem, we take the filament and I have a simple hand soap out the room and shampoo. I don't know if each one of them has what I think they have in them, but I challenge your test.
Okay, shampoo is going to have potassium hydroxide in it.
Exactly.
Which is going to be an electrolyte, which is going to make electricity from the salt of. So
Exactly.
your question is answered rhetorically that yes, potassium hydroxide is electrolyte that will make electricity. There's no potassium hydroxide in here. The only 2 things in here, and this was not done by any guessable processes. This is an 18-step process, and literally this is a condensation event. That's the best I can give you, and there is only those 2 things in this. We've had it tested by atomic absorption and proton absorption.
The characteristics that I see in the cell are going to be the same as just using one product, soap.
Yeah, we see that. That's what I said earlier. You're the king of crystallonics and done crystal cells. And let me give you guys a little background. Chuck Rothmeyer, Captain Bay, has done a massive amount of crystal cells. He's had them short-circuited, run, the whole 9 yards. We're not discounting that whole industry and what these guys have brought forward one bit. We've got graphene, which is a crystalline lattice. We have gold, which is a crystalline lattice. So we're still within the realm of crystal cells. We're not discounting what everybody has seen in the past. What this is just a refinement of that discovery and understanding of the crystallonics industry. Thank you, Chuck.
You want to test it?
We have no time because we only have a couple minutes here to test this, but we can drop some electrodes in it later, and I think the answer will be clear. It'll make electricity. We know that.
Cheers.
All right. Next question. All right, this concludes the technical session of my presentation for Tesla Tech 2015. Thank you guys very much for joining me, and I appreciate all of your work in all of your industries, and I'm here to help you, not to help you oppress your technology. So if you have questions and you think that you can't approach me, come approach me. Thank you very much.
Ladies and gentlemen, David Pakta and Biogem. Thank you.